Hi students, I am your Nagini ma'am, chemistry mentor. In today's session, I am discussing 3 excellent tricks for the important MCQs of Fajan's rule, 11th class chemistry chemical bonding. Okay, in today's session, students, after the end of this session, you will feel very easy to answer the MCQs of Fajan's rule. Definitely, you never lose marks based on this topic, students. Okay, now we'll start with one example, NaCl, KCl. Both are ionic compounds, we know that, but these compounds are exhibiting covalent character also. Covalent character also. Understanding? So, how this is ionic compounds and how they are exhibiting covalent character, that is explained by the Fajan's rule, students. Understanding? So, here NaCl, KCl, we know that ionic bond is formed between metal and non-metal, or in between the cation and anion, or in between the electropositive and electronegative element. Yes, sodium is a metal, chlorine is a non-metal. In between them, ionic bond is formed. By the transfer of electrons, ionic bond is formed. This is the ionic compound. But we cannot say this is the 100% ionic compound. Are you following? So here you have to remember, students, no bond is 100% ionic or 100% covalent character. Are you understanding? So that means these compounds are exhibiting both the characters, ionic and covalent. But how much they are exhibiting? 60% covalent or remaining 40% ionic, like that. Quantitatively we cannot say. Are you following? So it is Fajan's rule is completely qualitative property. Qualitative property, that is nothing but that is nothing. If suppose this compound it is more covalent, if it is more covalent, ionic character will be less. If ionic character is more, covalent character is less. So like that we can say. Understanding? So no bond is 100% ionic or 100% covalent. Covalent and ionic characters both are relative terms. Are you understanding, students? Both are relative terms. So that is nothing but quality. Okay, so no bond is 100% ionic or 100% covalent, students. So here covalent and ionic are both are relative terms. Are you understanding? It is a qualitative property. Fajan's rule is a qualitative property. It is not a quantitative property. That means how much percentage of covalent and ionic characters he could not explain, students. Understanding? So just if just qualitative property, that means more covalent, less ionic character, more ionic, less covalent, that much only. Okay, now just comparison. Right, now what is the Fajan's rule? It shows the amount of covalent character in ionic bond due to the polarization of ions. So here ionic compound is showing the covalent character, students, due to the polarization of ions. Polarization of ions. What is meant by the polarization? The distortion of electronic cloud of anion towards cation. Distortion of electronic cloud of anion towards cation, students. See here, first I will give the definition. What is meant by polarization? Polarization. See here, definition. Polarization of ions. What is meant by polarization? Polarization is nothing but the distortion of electronic cloud. The distortion of electronic cloud, of anion towards cation. So this is nothing but polarization, students. What is meant by polarization? The distortion of electronic cloud of anion towards cation. Now see here, I am giving the example. This is the cation, this is the anion. Positively charged particle, negatively charged particle. Here by the transfer of electrons between them, ionic bond is formed. Now here this cation is having the more effective nuclear charge. So that's why this anion is having the less effective nuclear charge. So it can attract the electronic cloud. This is the electronic cloud of anion. So cation is attracting the electronic cloud of anion towards its own direction. So that means here sharing of electrons takes place. That means these electrons are shared by both the atoms, understanding cation and anion, both ions. So that means this cation affected nuclear charge is more. So nuclear charge is more. That's it is attracting the electronic cloud towards its own direction. So that means what is happening? The distortion of electronic cloud of anion. Actually, this electronic cloud is like this circle type. How it is there? See here, because of cation, this electronic cloud, in the electronic cloud we can observe the distortion. There is a distortion. Understanding the distortion of electronic cloud of anion towards the cation. It is nothing but polarization. That means here they will get the partial covalent characters. Partial negative, partial positive charges will get. Understanding, it is attracting more this electronic cloud. Okay, now so that's it is getting the partial negative, it will get the partial positive, partial charges will get, partial covalent bond is existing. So that means here ionic bond, covalent bond, both are existing. Understanding, this is the ionic compound, it is exhibiting the covalent character. Are you understanding? Electronic cloud, there is a distortion in the electronic cloud of anion towards the cations. Understanding? So these electrons are attracted towards the cation. Are you understanding, students? So that's what happened. This electronic cloud, it is coming like this. Understanding, oval shape. Okay. So this is nothing but polarization. So this mainly polarization depends on the two factors, students. One is the polarizing power, another one is the polarization. See here, polarization depends on two factors. One is the polarizing power, polarizing power, another one is polarization. So here this is the polarization. Now see here, polarizing power, this polarizing power is the property of cation, students. It is the property of cation, and this is the property of polarization, is the property of anion. Are you clear? It is the property of cation. This is the cation property, it is the anion property. Okay, now see here, what is the polarizing power? Polarizing power is nothing but pulling ability of cation. So here it is pulling the electrons, understanding, towards its own direction. That is the pulling ability. Pulling ability of cation is nothing but polarizing power. Understanding, students? Pulling ability of cation. So this is a polarizing power is nothing but pulling ability of cation. Okay, next, what is the polarization? Polarization is nothing but that is the deforming ability of anion. Deforming ability, that means in the electronic cloud there is a distortion in the structure. See here, this electronic cloud is circle, but here oval shape came. Understand that means there is a distortion. That means what we can say, there is a deformation of the electronic cloud. That means deforming ability of an anion. This is nothing but polarization is nothing but deforming ability of an anion. Deforming ability of an anion. Clear, students? Polarizing power is the cationic property and polarization is the property of anion. What is meant by polarizing power? Pulling ability of cation. This is pulling ability of cation, and polarization is nothing but deforming ability of anion. That means how much distortion takes place here. Understanding, that is the deforming ability of anion. Deforming ability of anion. Now we'll discuss the polarizing power. It is the property of cation. It depends on three factors, students. Polarizing power. That means here, polarization of ions we can explain on the basis of two factors, polarizing power and polarization. Polarizing power is the cationic property, it is anionic property. Now polarizing power depends on three factors. One is the size of the cation, another one is charge of the cation, and last third one is the pseudo inert gas electronic configuration. Now we will discuss first one, polarizing power. So polarizing power, it depends on three factors, students. One is the size of the cation, another one is charge of the cation, third one pseudo inert gas electronic configuration, students. Understanding? So based on these three factors, we can explain the polarizing power. We can explain the polarizing power. Understanding, students? Polarizing power is more, polarization is more. Sorry, not polarization, polarizability, students. Not polarization, polarizability. Okay, polarizability. So here polarizing power, polarizability, both are more. Okay, na, then we can say polarizing power is more, polarization will be more. Okay, then covalent character is more, polarizability is more, covalent character is more. Understanding? So now we will discuss the polarizing power, size of the cation, size and charge of the cation, pseudo inert gas electronic configuration. Now see here, students. First one, size of the cation. Size of the cation. Size of cation. Now take here cations, nana, cation sizes. First we are discussing the polarizing power. Polarizing power depends on three factors. Size of the cation, first one. So size of the cation, I am taking the cation, this is the smaller size cation and this is the bigger size. See here, this is the size of the cation, small size, small size. This is larger size. Okay, small size. So cation size is small. What happens, students? Effective nuclear charge is more, easily pull the electrons, yes or not? So it can easily pull the electrons, easily pull electrons. Okay, na? So this one not easily pull the electrons, not easily pull electrons. Clear? Not easily pull the electrons. It can easily pull the electrons, it not easily pull the electrons. Easily pull the electrons means what happened? Polarizing power will be more. So here I am taking polarizing power. Polarizing power is more. Polarizing power is more means covalent character is more. Are you understanding? Now see here, in this case, not easily pull the electrons. That means polarizing power is less. So what we can say? Covalent character is less. Understanding? So what we can understand? Size of the cation. Cation is small. Okay, na? Then covalent character is more. Are you clear? Covalent character is more. Size of the cation is small. So smaller size, what happened? Covalent character is more. Understanding? This is the one factor, size of the cation. Now we will take one example, students. See here. Lithium, sodium, potassium ions take Li plus, Na plus, K plus. See here, in these ions, which is having the more covalent character? Which is having the more covalent character? Size of the cation. Size of the cation is small, more is the covalent character. So size of the cation, which one is small? Lithium ion is small. Li plus cation size is small. So cation size is small, that's why its covalent character is more. Are you following? So its covalent character is more. Understanding? So this is the order. Now coming to the charge of the cation. Now take here example, charge of cation. Charge of cation. See here, what is the charge of cation? In case of charge of cation, students, charge of cation, I am taking cation, less charge, more charge. Two examples we will take. So this is the more charge, charge of the cation. More is the charge, here less charge. See here, charge is more here. Four positive charges, here only one positive. So here charge of the cation is more, here charge of the cation, here charge is more. Are you following? Charge more here, here charge less. Okay, charge less you are taking. Charge is more, then what will happen? So smaller size, effective nuclear charge is more, it can easily pull the electrons. Understanding? Easily pull electrons. Easily pull the electrons means what we can say, students? Easily pull the electrons, polarizing power is more. Polarizing power is more, covalent character also more. Now here charge is less. Charge less means it cannot easily pull the electrons. Understanding? Not easily pull the electrons. Not easily pull electrons. Understanding? Not easily pull the electrons. Next, polarizing power is less. Polarizing power less means covalent character also less. Are you understanding? So what you have to understand here, charge of the cation. Charge of the cation is more. Okay, charge of the cation is more. What we can say, students? Charge of the cation is more. Covalent character is more. Are you clear? Charge of the cation is more. Now coming to the third. Here one example. See here, charge of the cation based on this one. Na plus Mg plus 2 and Al plus 3. See here, which charge is more? Here charge is more, plus 1 plus 2 plus 3. So charge of the cation is more. More is the covalent character. So that's a, what is the order, students? Less than. So it is having the covalent character more. Clear? So this is understood, Amma? So this is the covalent character more. Next one, third factor, pseudo inert gas electronic configuration. See students, superhero cations. Third factor is pseudo inert gas electronic configuration. What is pseudo inert gas electronic configuration? Means the suppose we are taking example Cu plus and Na plus. Here Cu plus is having the pseudo inert gas electronic configuration. That means it has 18 electrons in their outermost shell. Understanding? Cu plus copper electronic configuration 29 ka the atomic number. So electronic configuration for argon 4s1 3d10. One electron lost 3d10. That means it has 3s to 3p6 3d10. That means total 18 electrons are present in the valence shell. So that's why it is showing the pseudo inert gas electronic configuration. Understanding? So those elements are calling as superhero cations. Are you following? Superhero cations. Understanding? So here what are the superhero cations? So coinage metals, copper, silver, gold. These metals are used in the preparation of coinage metal, students, coins. Okay, these are calling as superhero cations, and these cations are present in the compound, then we can say that covalent character is more. And last group elements in D block elements, students, last group zinc, cadmium, mercury, these elements are also having the more covalent character. These are also calling as superhero cations. Understanding? So these elements are showing the pseudo inert gas electronic configuration. Now we take here example Cu plus and Na plus, which is having the more covalent character. So which is showing the pseudo inert gas electronic configuration, or which one is superhero cation? So that is having the more covalent character. So Cu plus is having the more covalent character because its electronic configuration Cu plus, it is argon 3d10. Argon 3d10. That means here argon means what you will get electronic configuration 1s to 2s to 2p6. 3s to 3p6 of 3d10. Clear? 4s1 one electron lost kada. Total how many electrons? 2 plus 6 plus 10. Total how many? 18 electrons are there. So it is showing 18 electrons. So it is a pseudo inert gas electronic configuration. So this element belongs to superhero cation. Which is a superhero cation? That element is showing the more covalent character. Are you following? So this is the more covalent character. Understanding, students? This is about the polarizing power. Are you clear? So more polarizing power, more is the covalent character. It is completely, we discussed about the cation. Understanding? So here polarizing power is a property of cation. It is depends on three factors: size of the cation, charge of the cation, and pseudo inert gas electronic configuration. These three factors completed. Now we are discussing about the anionic property. What is anion, students? Polarizability. So this is the polarizability. Polarizability is the property of anion. Okay now, so property of anion. So polarizability depends on two factors, students. One is the size of the anion, another one is the charge of the anion, students. See students, polarizability, it is a property of anion. That means what is the polarizability? Deforming ability of anion. Yes or not? That means there is a distortion in the electronic cloud of anion by the cation. That is nothing but polarization. Yes or not? So that means there is a distortion in the structure, students. A distortion in the electronic cloud. That is nothing but deforming ability of anion. It is a property of anion, depends on size of the anion, charge of the anion. Now coming to the size of the anion, see here. Here anion size is small, here anion size is larger. Okay, larger size, smaller size. Smaller size size is there means anion size not easily deformed. Understanding? Because here cation size is small, anion size, if it is small, what happens, students? This is also having more effective nuclear charge. Yes or not? So that's a cation cannot it cannot easily attract the electrons. It cannot change the distortion. It cannot change the electronic cloud. So that's why here not easily deformed. But here whenever size is more, anion size is more, what happened? Easily deformed. Yes or not? See here, easily deformed. You see here anion size. Here anion size is more. Here small cation size is small. Okay, now this size is more. Whenever size is more, then these electrons are easily attracted towards the cation. That means we can observe the more distortion in the electronic cloud. Here this is the there is a distortion in the electronic cloud like this came. Understanding? So that means more is the size. So larger size means what happened? Easily deformed. Are you clear? Easily deformed. So that means easily deformed means what students? More polarizability. So polarizability is more. Clear? Polarizability more. Polarizability more means covalent character more. Here polarizability less. Polarizability less, covalent character also less. Clear, student? So here what you have to remember, students? Size, anion size should be larger. So anion size should be larger, then covalent character will be more. That you have to remember in case of size of anion. Now coming to the charge of anion. Now coming to the charge of anion, students, what you have to say? Charge of anion. So in the charge of anion, I am taking here more charge. Take one example. Charge of anion, this is having the less charge, it is having more charge. So here it is having less charge, it is having more charge. Clear? This is anion, more less charge, more charge. Here 5 charge is there, more is the charge. So what happens, students? More is the charge, more is the size. So whenever size is more, effective nuclear charge is less, than easily deformed. So here it can easily deformed. Understanding? That is deforming ability of anion is more. Easily deformed. So easily deformed means what we can say, students? Polarizability more. Polarizability more, covalent character also more. So you have to remember here less charge. What about the less charge, students? Easily deformed? No, not easily deformed. Clear? Not easily deformed. And here polarizability less. Next one, covalent character also less. Clear? So here what you have to remember? More is the charge. Okay, see here, more is the charge, covalent character is more. Clear? More is the anion charge, more is the covalent character. Are you clear, students? So this is about the polarizability. This is the property of anion. Now I reveal the tricks, students. I told you 3 excellent tricks. Now I am revealing. See here, trick number 1. Trick number 1, size of ion. In case of size of ion, cation size is small, anion size is more, covalent character will be more. Are you clear? This is the trick number 1 in case of size of ion. Next, trick number 2, charge of ion. Charge of ion, cation size, no, there is charge of ion, cation size, anion, cation charge, anion charge. Cation charge more, anion charge more, both more also, covalent character will be more. Trick number 3. What is the trick number 3, students? Superhero cations, pseudo inert gas electronic configuration, Cu plus Na plus. Here Cu plus is showing the super inert gas electronic configuration, pseudo inert gas electronic configuration. So that's its covalent character will be more. Just remember these 3 tricks, students. You can easily answer. Cation size is small, covalent character will be more. Charge is more, covalent character will be more. Are you clear? And here pseudo inert gas electronic configuration is there, that covalent character will be more. Understanding, students? Now we will discuss the MCQs of Fajan's rule. Clear? See here, important MCQs of Fajan's rule. Increasing covalent character you have to write. Some examples I am taking here. NaCl, NaBr, Na. Which is having the more covalent character? Increasing order you have to write. See here students. Sodium, sodium, cation, 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 same. Now you have to see chlorine, bromine, iodine. Anion you have to consider. Okay na? Sodium, chlorine, bromine, iodine. Sodium is constant. See here sodium, here sodium, here sodium. So same element is there. You have to neglect remaining. Now what are the anions? Different anions, different elements are there that you have to consider. Chlorine, bromine, iodine. Now here anions, chloride, bromide, iodide, size is more. Which size is more students? Iodine size is more. So already I told you anion size. This is anion. So I told you anion size is more. Anion size is more is the covalent character. Correct or not? Here I told you trick number 1. What is the trick number 1 students? Covalent cation size is small, anion size is, here see here trick number 1. Cation size small, anion size should be more, then covalent character will be more. Clear? So you have to take here size, Nana. Understanding? You have to consider here that we have to consider here size. See here chlorine, bromine, iodine. Iodine is the anion. Its size is more. Are you clear? Its size is more. Size more. Anion size is more. Anion size is more. Then here what you have to say, polarizing power will be more. Clear? Polarizing power is more. It is the It is anionic property na. So only polarizability is increases. Polarizability more, then covalent character will be more. So here what is the order students? This is the correct order. Clear? Because it is anions kada. Anions property, which one students? Polarizability. Polarizability is anionic property, that is deforming ability of anion. Now coming to the second bit, see here lithium chloride, LiCl, NaCl, KCl. So here which is the common students? Chlorine is the common. So here which is the changing? Cation changes. Lithium, sodium, potassium. Which size is small? Lithium size is small. So here I told you cation size is small. Here I told cation size. So here cation size is small. Cation size is small. Cation property, which one? Polarizing power will be more. Polarizing power is more. Covalent character will be more. So here lithium chloride, it is more covalent character. It is having the more covalent character. This is the order. Clear students? Now coming to here next example, fluorine. See here fluorine same. Now you have to consider cations, beryllium, magnesium, calcium. Which size is small? Beryllium, magnesium, calcium. Beryllium size is small. Cation size is small. Clear? So cation size is small. Then what you have to say, polarizing power is more, then covalent character will be more. So here what is the order students? This is the more covalent character. Now here Na plus Mg plus Al plus Si plus 4. Here we have to consider charge. Here plus 1 plus 2 plus 3 plus 4. More is the charge. Second trick number 2. More is the charge, more is the covalent character. Are you clear? So here Si plus 4 is having this one. So more charge. Okay, the more charge, covalent character will be more. Clear? So next one, CD plus to Ca plus 2. Which one is more covalent character showing? CD plus to Ca plus. See, CD is the which one students? It is a pseudo inert gas element, last group element, zinco, cadmium, mercury, I told you. So cadmium, it is it is a super heavy, which element students? It is a superhero cation. Clear? It is a superhero cation. So that's why it is having the more covalent character. So this is the correct order. Next one, K plus and Ag plus. Here Ag plus is a coinage metal. It's a more covalent character. It is showing the more covalent character. And Cu plus and Na plus, which is showing the more covalent character students. It is a superhero cation. It is showing the more covalent character. So this is the order. Au plus and Rb plus. Au is the coinage metal. Its covalent character will be more. It is a superhero cation. Covalent character will be more. So superhero cations, silver, gold, and copper. And another one is zinc, cadmium, mercury. These elements are there, means those elements are showing the more covalent character students. Are you clear? So these are the important MCQs of Fajan's rule students. Here I discussed 8 examples. Okay, now so you have to remember this 3 tricks, Nana. Trick number 1, trick number 2. Okay, trick number 2 and trick number 3. Clear? Trick number 1, 2 and trick number 3. These 3 tricks you have to remember students. You can easily answer based on this topic any questions, Nana. Okay, thank you students. I hope you understood this video. If you like this video students, please like, share, comment and subscribe my channel, Nana. Thank you students.